All right, good morning, everyone. I hope you are doing fine. We are going live for a new session from our next show. And today we have Professor Amit Sheth, and you can already see him on the screen. And we're going to be talking about uh, artificial intelligence in manufacturing. And this is a super exciting topic. And I'm so excited that when I come from the world of manufacturing and I talk with someone from the world of artificial intelligence and we try to merge things together. Ahmed, good morning. How are you doing?
Good afternoon.
Good
It's
afternoon. Yes, it's 1 minute from noon. How
oh,
are
it
you
is
doing?
only afternoon. Yeah. Oh, wow. Okay.
How are you doing? How's everything?
Doing great. Excited.
All right, awesome. So you just moved a year ago to South Carolina. How has it been going so far?
Oh, wow. It's been a ride. We came under very special circumstances, but even in spite of that, I moved with my team. We were seven to start with. Now we are about 15. Sorry, 25. So we have grown tremendously, and so many collaborations going on, so many activities going on. Already, I think executing very well.
That's awesome. And I mean, we both are. You're my first guest from my college, so we're both from the College of Engineering and Computing at the University of South Carolina. So I will have another guest in this season from USC. I try to make sure to keep it balanced between my colleagues and the outside world.
Yeah.
So Amit, we're going to be talking about the exciting topic of artificial intelligence in manufacturing. But before we do that, let me go ahead and introduce you for those who are not very familiar, I which is going to be very hard for me to believe someone is not familiar with your work. So you are the founding director of the AI Institute at the University of South Carolina. Your research is on AI topics, on knowledge infused learning, KIL, on neurosymbolic computing, and you have a translational research you do within CEC, within engineering, but also like I know of your work in health sciences, and especially now with COVID, I think you've been helping the university like pretty much on that. You're a fellow of IEEE, AAAI, and AAAS. So let's go ahead and get started with the topic. And there is so many people throwing greetings to you already. We have Dr. Fernando Mas saying hello. We have Dr. Al Najm, Dr. Gohil. So we're having a lot of feedback from LinkedIn and Dominic Chettini. So thank you so much, everyone. Keep in mind that at any point, please post your questions and I will make sure to integrate them. I have access to them and I can integrate them, and me and Amit, we will answer them. All right, so let's go ahead and get started. This is the outline of your talk. So, what is it for today's next session? What are we talking about for the next hour?
Well, you asked me to talk about AI in manufacturing, so that is what we are going to talk about. I obviously within an hour we can only cover so much. I think that I'll be successful if I'm able to, uh, describe to the audience the key challenges and opportunities and some semblance of the approaches to solve the problem. So
All
that's what
right.
we do.
That's awesome. So I hope at the end of the session, this is what will be the big takeaway for our listeners. By the way, for some reason, people are saying hi from where they are from, which is amazing. We have hi from Zurich with Thomas. We have hi from Istanbul with Mustafa. We have hi from Dubai. So with Muhammad. So please throw where you are listening to us from this morning. All right. So, can you introduce us a little bit to the AI Institute in South Carolina?
Right. So this is a university-wide institute, and uh, we want to be among the top, not just in the core AI research, but in translational research and in interdisciplinary. multidisciplinary and transdisciplinary research. So um, uh, US needs to do more progress in applications of AI and achieving its impact, and that's one of the core aspects that we want to do besides the research that we do in academia. And we have great offering of courses, and um, but more importantly, we have amazing engagement across the university already. If we can go to the next slide.
So when you say translational research, like what does this mean? The term translational research, what does this mean?
uh, as an analogy, the translational research in biology was about going from lab to bedside, from the bench to bedside. So from core research in biochemistry and biology in life sciences to actually be giving the clinical care. Similarly, translation research in a broader sense is where you are doing core research, but then you're taking all the way to the real world. You are seeing it because your software is deployed in the real world. You are seeing it because the products that come out of that, or you license your technology and new companies are formed. In all of these cases, essentially, you have translated the core research into the applications.
All right, this is awesome to know. So, university-wide mandate. Talk to us a little bit about that.
Well, in this short time, we have joint research and collaborations going on with practically all the colleges. Only two or three that we don't have collaboration with. As you know, your University of South Carolina is a a flagship university for the state. It's a full university with all the colleges, all the subjects that are being taught, and high quality research is being done throughout the university in different colleges. So we started our mandate is to kind of take AI and help achieve the progress in all variety of disciplines. And here I show the list of colleges with which we already have collaborations. The largest number of collaborations are with medicine and nursing, but then with all the other colleges. So I've mentioned some examples thereof. And as coming to your question on the translation research, the last line that you see, that defines translation, where we start with real world challenges, engage with the experts and users in that particular area, get the real world data, do the research, build the applications, deploy it, test it, evaluate it, and look for the impact either through commercial or scientific or other outcomes.
All right. So so let's delve into our topic. Now that you've introduced the AI Institute, let's talk about AI in manufacturing. What are like the big changes in manufacturing that need artificial intelligence?
Um, the number of technologies coming into manufacturing is growing rapidly. In fact, has already grown very rapidly. Automation has come into manufacturing, and the standalone automation has done well. You put in the robots, and they do repetitive tasks that humans used to do. That has done very well. But now we are getting to the stage where the automation is not in isolation, but is integrated across the factory, across the entire business life cycle. So you have robots, Internet of Things, digital twins. Um, Other interesting things that are happening is business centric, like change in the supply chain. In last 3 to 4 years in US, there has been political and other aspects pushes that has led to significant pressure on the manufacturers to change their supply chain. So that's another challenge. And there are other issues that manufacturers are supposed to do better at, such as sustainability, traceability of everything, accountability of anything, environmental impact, and so on and so forth. The result is basically in all of these things, all these activities generate data. So it's called, somebody uses the term data tsunami. And, I've seen the estimates of nearly 31% growth, annual growth over the next 5 6 years. So when you have such growth in data, what can you do with it? I mean, you need to use that data for getting the recommendation, for doing the better planning, for making better decisions. That's where AI comes in. And again, I've seen a numbers such as more than 57% year-over-year growth in AI related solution to manufacturing. So this is a very rich area where fundamentally huge growth in data creation that demands AI use of AI so that humans can make timely and better decisions.
So what is CAGR?
This is basically the economic term for essentially uh, growth in the revenue in that particular sector year over year.
All right, awesome. So what is Industry 4.0 that we're talking about right now?
Yeah, so basically, this quote that I took from the source that is given there, it says that essentially Industry 4.0 is information intensive uh, effort. The transformation is all led by data and information. And that is essentially now supporting what I tried to posit earlier on. And it basically means that making smarter manufacturing, making so-called factory of future, all of this is going to be centered around effective uh, analysis, collection, analysis, and use of data. And that will be by computational systems, that will be by computational system mediated for humans to make to engage with each other and make decisions.
This is awesome. So for our users, just a quick minute to make sure that this terminology is not just another buzzword. The world of manufacturing has coined the term in approximately the between 2008, something of this kind. And we have industry 1.0, 2.0, 3.0, 4.0. Very, very, very quickly, industry 1.0 is when we started using machines and equipment in the late 1800s. Industry 2.0 is mass production in the 1930s when we needed to produce massively and move from single ones to several ones. Industry 3.0 is like the 50s, 60s when we started using CAD CAM systems and automation and robotics within the manufacturing spectrum. And what Professor Sheth is just talking about right now is Industry 4.0, which is we are in today, is the capacity to sense, get data, and as the slide says it, do actionable items. So this is something very, very important. When we're trying to marry manufacturing and AI, it's important to know where manufacturing is trying to situate itself. So,
And the interesting thing here, if I may add to what Remy only said, is that the incremental benefits to manufacturing concerns are largely going to come not just through the use of machinery, but through the effective use of data and effective analysis of data, using the data. So this one, I just wanted to put forward couple of important quotes. Our ability to generate data has grown exponentially. The number of sensors on a manufacturing line have grown. Sensors are very cheap to install. What is not cheap to install do is to make use of that data in a timely manner. So the AI, and those are my words. AI is about converting data into knowledge, insights, and action.
all right, this is awesome. So we do have a question for you.
Mhm.
What is the role of human expertise and decision making in the future of manufacturing? I think we're jumping into the core question with Deborah John. And is it secondary to AI basis decision making? So I don't know if this is something we're gonna cover today, but what's your answer to this?
Well, at the end of the day, in fact, my own perspective is that AI is about making humans more effective. There is a part of AI which is to replace the human, and Marvin Minsky and others who were, some of the original thinkers in AI, talked about replacing um, humans with machines, and that we already started to, get that kind of AI is very widespread in manufacturing, particularly all the automation that has happened with the robots and robotic arms and conveyor belts. with things connected. The next stage of AI and is more around making effective decisions, and decisions are typically made by humans. So uh, huge amount of data that is generated cannot be analyzed by humans. But converting that data into this knowledge, insights, and choices in the decisions, that is what the kind of AI that we'll discuss today does for us. And then human, I think, will remain and should remain integral part of the system, except all the routine things are going to be done by automated systems, all assisted by AI technologies, embedded with AI technologies, and all of the kind of more of a strategic nature, more of the things that involve new changes, those are all done by humans. So routine day-to-day aspects are already highly automated, and what you're going to see more is where the AI will have humans in the loop, but AI is there to assist humans for better outcomes.
I am in complete agreement. And Deborah John, there is somebody who gave you a link to another lecture by Amit as well on the topic. And Dominic, you asked a question that I'm going to keep it till the end. So this is a very important question. And I'm going to wait a little bit on, we have tons of feedback and questions so that we can move a little bit in the chart. So Amit, you've mentioned factory of the future, and this is something that's very dear to my heart, and we've been cooperating on this. From your perspective, what is expected for the factory of the future?
Right. So here I have listed some of the core benefits. What a factory of future should deliver. What is the reason why people talk about factory of future? Defect detection is throughout the production process is an example. Predictive maintenance to reduce downtime is another one. Real-time changes to demand in demands across the supply chain is yet another one. Reduce the cost of small batch or single run goods is another one. And keeping humans who are still in the manufacturing process happier is yet another one. So these are some of the main reasons that are given for the fact, that calls for factory of future, that the factory of future should deliver.
Awesome. So AI, what's the benefits of using artificial intelligence in manufacturing? And this slide actually, after you finish from it, we have a question from Dr. Abdullah Al-Najm that you might answer it as you're talking about the slide. Is the benefit of AI more on reducing errors that the AI notices, or is it about quality, better quality products? So as you're talking about the slide, it would be good to tackle this question.
Right. So the benefits of incorporating AI are along these lines of improving the production. That is the biggest reason. Streamlining R&D is yet another reason, and even work with the sales and marketing is yet another one. The first one is the most important one, and you can see here in the bullet list a variety of high level reasons or the benefits that are supposed to be garnered if you're going to apply AI. Now the answer to the question is more along the first line, that at least currently the emphasis is on reducing the errors, having the machines find the errors automatically. So with, for example, continuous monitoring of the parts and materials that go into production process, finding the defects right away, both in the inputs at all stages of production to the part that is created, and automatically figuring out, oh, there's something wrong with this. Stop the process. Don't, there's no need to process this any further. So that kind of things is where the current emphasis is. That doesn't mean the second part of the question should not be addressed, but I think that's going to come a little bit later.
All right, awesome. So
So this is just one concrete example, and that was, again, the question was about this: what is the level of the cost? Um, and these are in fact somewhat older numbers. I created this slide a few years ago, but here in example, loss per minute when an auto plant stops due to failure, or how much they spend on warranty, for example. So the idea is that, hey, would we not produce the our products that are much higher quality? At the end of the day, you see, let's say in automotive, the manufacturers and assemblers who have least failures post production are the ones that are succeeding in the longer term. So the whole idea here is that um, using the technology to prevent the failures and finding the errors is a huge opportunity. So that's where you say reactive, preventative, predictive, and proactive maintenance strategy for your plants and manufacturing processes is what people have been talking about. So this has been what has been driving the investment in this particular area about reducing the failures in manufacturing.
This is new also to me, and I like this because you often hear that preventive maintenance is very very important. And basically what we're trying to say, what I understand from here is, it's not about preventive, it's not about reactive, it's about finding the right mix between those two, as well as adding to the mix the predictive and the proactive maintenance strategies. So this is very, very important.
Yeah, and if you think about it, the business models that we used to have earlier, in a decade or two earlier, the whole idea of creating a product and then putting in the market and then after service aspects of it, that worked. You had in the automobile, you had, for example, people who the dealers who service your car, or other shops that will service your car. Now the customers do not want to have to go through maintenance of the vehicles, as an example. And the same thing that is also happening, let's say you sell an HVAC system. The idea is that if you can prevent from the HVAC system being broken down and then repairing it and do the part replacement, uh, instead proactively maintain it in a timely manner, then you have a lot more savings and customers are a lot more happy because they are relying on these products, and they themselves have cost when the parts and products fail.
All right. So what is AI in manufacturing?
Well, here I just wanted to make the point that what we are talking about still is kind of leading edge, in that in reality, today, even though it is one of the hottest topics in manufacturing, most manufacturers are still at a start of the adoption curve. So there is a lot more to go. And that was one of the reasons why you saw that AI in manufacturing CAGR was shown to be 57%. That's a massive growth year over 57% growth every year. That estimate is pretty large. But that this is the reason why so far I think the values are very well understood. Research is coming up very fast, and I think that the time is just right to start incorporating that into the into the plants and products and manufacturing in the real world. So that's basically the point we want to make.
I'm in agreement. There is a question that is like, you talked about AI and manufacturing in the world, in the industrial world. There is a question we have from Hatem that says, is the education system at US universities working and enhancing the curriculum to prepare future students for the market?
Well, Remy, you know as much about this as I do, because we have done a joint proposal exactly in this area. I think this is a big challenge in the US. Remy and I did, along with the faculty from education, did a proposal, and the idea is that typical students are not quite as well prepared to function effectively in this world with lot more automation and this much of AI, this much of technology. And the kind of thing that Remy is working on, Factory of Future, that's quite further off from what typical students are being prepared for. So clearly there needs to be significant more investment such that the workers that will be needed on in this Factory of Future are ready and prepared. And answer generally is that no, today that's not the case, and we really have to address that challenge also.
Yeah, I mean, this is, first of all, it's so interesting, the proposal that we've worked on together, and all these ideas where we're actually trying to penetrate the education market and tell it that, hey, there is something that is needed, there is something that is missing, and I hope that we continue the work together. So I'm sure that, I mean, within the ecosystem at the University of South Carolina, we are trying to be really cutting edge when it comes to this. I mean, we have, like, our dean has the right leadership and vision, and like I always tell him, I'm thankful that he pushed that you come down to USC, because all the common work and the ideas that were coming up together is just super exciting. So let's move on to what are the key AI sub areas when we talk AI in manufacturing.
Right. So these are some of the key areas of AI, and each of them have specific applications and relevance to manufacturing. At a very high level, robotics, everybody kind of is aware of that, and there's a significant use of robotics in the factory, and there's the robots are becoming much more flexible, much easier to program. They can do multiple tasks better. They have better, for example, grips than we used to have before, so they can do more tasks that required humans to do and manipulate the parts and such. They have much better vision integrated, so they can look at the parts in all kinds of directions and so on and so forth. The part that actually and the associated to that is this computer vision, where basically you are able to create an image or video of anything that is on in the production process, anything is on the manufacturing floor, and understand what is going on. For example, to identify defect earlier on, identify defect that will be hard for human eye to identify. So that is the area of computer vision, which is essentially understanding, processing images and video in understanding, so kind of human eye and associated processes. That's what vision is about. The area that actually I'm going to talk most about is the integration and interoperability, integration of data. And there, this item you see, knowledge graph, plays a huge role. And it's an area of AI that has grown very rapidly and is growing rapidly very recently. So last 3, 4, 5 years is seeing huge growth there. One interesting point I would make is that today's biggest internet companies, we are talking about Google, Amazon, Apple, Microsoft, Alibaba, Tencent. These are the biggest, most highly valued companies. And after, in the 5 to 10 years ago, it used to be machine learning and deep learning which was getting the most attention. Last 2, 3, 4, 5 years is the knowledge graph that is getting a lot more attention. You might have heard of knowledge graph since Google in 2012 came up with the new semantic search, which has integrated knowledge graph. So the same value that knowledge graph gives to the web search gives similar advantage knowledge graph gives to the manufacturing applications. And then there are other fields of natural language processing and conversational AI that you can talk to the machines and mobile platforms by voice, let's say, and interact with the automated systems more flexibly with more senses that humans have.
I have a dream to create a conversational AI that I train for student questions, and like this, you get automatically some answers. So perhaps someday I need to roll up my sleeves and start working on that.
Yeah, we have a pretty large program in conversational AI right now. For example, we're building applications for depression, mental health and depression, and several other cases. We already have one for asthma in children. So, and then we will be working towards education. So that's where I think you are talking about. And yeah, this is a very exciting area.
So we're moving on to section three. I mean, this is super exciting, and the amount of comments and feedback and the viewers we have from all over the world is very, very exciting. So let's delve more into the details of. You mentioned one of the key areas we just talked about it is knowledge graphs and ontology. So let's delve a little bit more into this section. Tell us, what is it that we're seeing in here?
So here we are seeing a typical network architecture for factory of the future. We already talked about factory of the future. In a simplistic way, the bottom layer is also so-called shop floor or end tier is where you have all the Internet of Things or devices. These are all the things that create data. And this data, once they are created, either has to be processed right there, or the data has to be passed on to the next level called fog. So for example, a part of the factory and a computer supporting a part of the factory could be a fog, and they may talk to each other. There is a device that some people that is called gateway that may also reside at this level, which kind of combines collects data from many devices on the floor and passes on up there. And then the top floor is the cloud tier, where heavy duty processing goes on. Traditionally, data is created at the bottom level and put up all the way, sent it all the way there, where very high-end computers work towards, let's say, analyzing an image and find out where is the defect on the image. I'll talk about the some new things that are coming, where it's called edge AI, where more of the computation is computation is coming closer to the data source or data acquisition. Let's go to the next slide. So this is Remi's setup, in McNair Aerospace building. You see he set up on, this may be older picture on the right hand side, the actual cell, and there's a digital version of it, and it's kind of already supports digital twin aspects of it. But a point here is that in the previous slide, when you saw the bottom layer, that is where all the sensors are. So here Remi has sensors that are built in the hand of the robot arm. There are sensors that are looking at the elbow and of the robot arm, and where there if there is a higher temperature, there will be concern. There is a drone that they fly that takes picture of what's happening on the robot, on the shop floor, whatever you call the cell floor. So, and these are just subset of these. So there are all kinds of sensors. The amount of data that these sensors can create is humongous, and that's at the bottom layer. And then comes all the high level that we'll talk about in the future slides.
I just want to point out, I'm so glad that my setup is in your slides, and this is really, like, I want to shout out to the amazing team that I have, the next years that have been working so hard to set it up, like Clint, Kaishu, Chris, Drew, Alex, Josh, and so on. So I don't want to forget anyone. So thank you for including this in your charts.
So now what happens is that you have these devices like or a sensor, and the data is collected, and then that data is sent out to some place where there will be either it will be passed on further on, or there will be computation there. So you see that the first blue box there, device and protocol interoperability. Next comes, and there are issues with regards to, because you buy these devices from different manufacturers. So the language is, the format of the data that each of the manufacturers use are different. So you have problem dealing with the combining the data, and that's what you mean by interoperability from multiple devices. But you need to understand all of them. Even if you have robot, and robot arm has a sensor, and then you have outside sensor that you bought from another manufacturer. Well, if they're looking at the same part, then you need to be able to talk about that both of the sensors are giving information on the same part. How do you know that? So there are problems there. Then the data interoperability is that actually the way the data is packaged is different, and that is the issue. And then semantic interoperability is that the way the language that is used to describe, and in the future slides I will describe this in more detail. That is different. The language used, just like humans have different languages again, and to associate the meaning with the data. How you do that, that is also very important. That is where you need semantic interpretation of the data you're getting. So way back in 2004, where I was running my second company, I introduced this term called smart data, saying that because the word, and this was before the word big data was coined. But the point is that this big data, where you have large volume of data, many variety of data, data comes very fast, so-called velocity. These are big challenges, and humans are not equipped to analyze all the data and making that data meaningful for the decision the humans have to make. Well, to imply that, I use the word smart data. The same thing is that, say, smart data applied to IoT is smart IoT. So this is the term that I had coined, I don't know, maybe in a few years ago. The citations there. But and that these terms are now very, there are industry conferences on smart data now. And also smart data, IoT also, the article I wrote is very, very highly, I think, followed. But I think these are the interesting concept, that you start with this data that a device generates, and there's a long path to actually making a decision involving that data. A decision is not usually based on data from a single device. This is based on data coming from many devices, many sensors, and there's a lot of technology that goes to make that possible.
That's really, really exciting. I'm glad you called it smart data, not intelligent. Like it makes the word shorter for us nowadays when we're dealing with it. All right. So what is
So
it all about the semantics at device and the factory floor?
yeah, so it just shows you, first of all, here on the left hand side in the picture, you see there are different devices, different sources. This is not a manufacturing alone picture. It may this has but basically, even in the manufacturing, there'll be a lot of different kinds of devices on that are shown on the left hand side. And then you see there are all these protocols. So COAP and MQITT, these are some of the network protocols. And then there is a machinery called gateway. So one of the concepts that I had introduced several years ago is called Semantic Gateway. That basically allows you to forget that data is coming over different protocols. So you can now simply focus on what data is rather than how the data came to you. And then you have applications on the right hand side. So basically, and the other thing is that if you take all the data coming from sensors and just send it out on the cloud, all the way on the left hand side for use by applications, there's a lot of bandwidth required. And instead, the idea is to make the data smarter, so fewer amount of data is to be passed on. You pass on what is important in decision making rather than every other things that is a noise.
And and sometimes, I mean, this is important because sometimes you have the hub where you're collecting the data that is remote, and you don't want to transmit, like, let's say it's the robot head or it is on a drone somewhere, and you don't have the capacity to stream like millions. So you have to make some intelligent decisions on the system itself before you transmit it to I mean, the general spectrum application. So I have a question for you from Kaishu. Are there common methodologies to deploy developed knowledge graph ontology to generally accepted industrial hardware?
The knowledge graphs or ontologies are not implemented typically in the hardware yet. That is what will come with the edge AI. Right now, they are typically at the level of gateway or higher on. So, in the three-tier architecture, there will be something happening at the fog level and then something happening at the cloud level. And that is where currently the things are. They are moving closer to the edge or devices, but they're not yet there. There's a long way to go there. We just had, for example, one of my colleagues had project funded where you start doing machine learning on the device, and we have worked along this line of pushing the semantic processing closer to the data creation, but it's kind of more of a research phase right now, not something that is very well understood.
That's awesome. Kaisho is by the way, is a next year. He's one of my PhD students. I have a question that is not really relevant to what we're talking about now, but let's go ahead and tackle it by Mohsan. What kind of skill sets does a student need to learn to build a career in manufacturing based on AI Industry 4.0?
Very good question.
It's a beautiful question.
Yeah, it's a very good question. I think right now, um, the answer is like you need to join my group or Remi's group because they do collaborative work, and we will work on projects that involve both AI technology and manufacturing. There are tutorials and possibly mini courses, but there is no significant. There is, for example, an offering from Ohio State University on manufacturing and big data. I am unaware of anything significant in manufacturing and AI per se. Uh, to
Amit,
institute,
can I add something to your answer? And you've not received my email yet, but this is something that internally at CEC we've received the green light to start working on, and this is something that we fundamentally believe this is the future. South Carolina is a manufacturing state. The world of AI and manufacturing is, whether we like it or not, is going to be the dominant one. And this skill set is going to be what is needed in 10 years as one of the top things. So I'm just sharing it that this is something that we have the green light to work on, and we are actively working on. So we're going to start with a master's program, of course, and then we're going to try to trickle it down to undergrad or PhD. But our starting point is going to be a master's in. We don't know if we're going to call it smart manufacturing. You're the expert in calling things, so perhaps at one point we will, but it's going to be, this is something that is on our radar. And a big shout out to Clint Sadie, who's been working with the whole team to create like a definition of the courses that eventually we need to propose and so on. So this is something that, as you said, right now, I would say joining our teams would be a great segue, but we are also working to make sure that this becomes a track and available track.
Yeah, AI Institute is also, keeping an eye open for developing interdisciplinary AI programs. So there are, in computer science, there are, few AI programs, but I don't know of any interdisciplinary AI program. So we just are assessing the market and the need and other things. And when we find that and have, grown enough to be able to conduct the courses, then I think that's an area to do. The
That's
question
awesome.
is whether we are, it's a residence program or, online.
Yes.
Those are things that we need to figure out.
So there is a follow-up comment that is talking about control and advanced control, which I agree with. Control is part of the game. So let's move forward. Data interoperability.
Yeah. So let's just notice that there are a variety of data. Structured data, you can see on the left that I've listed some. Unstructured data that I have listed, next. And let's move on to the next slide because we'll be running out of time very soon. Let me give you this analogy. This is an analogy from a project that we have already been working on for last 4 years. This is for asthma in children. And what you see here is a project called K-Health. K stands for knowledge, or knowledge as in knowledge graph. And here we are, for every child, we have 29 different parameters that are collected. You can see in the green are data collected online through web services. In the light blue are the data connected through devices, sensors, and and also dark blue is data collected through indoor sensor. The light blue is data collected on the patient itself, and then there is a mobile app. So 29 different parameters collected, and 1852 data points per patient per day. Now 1852 is not a very large number, but when you consider there are 29 different parameters, what do they mean in trying to understand how good is the human health, how well is asthma controlled for the patient? That is the challenge. So you have all this data. Asthma is is a multifactorial disease, so you can get asthma triggers because of high pollen or poor air quality, or not taking medication in a timely manner. A lot of things can go wrong, right? Similarly, a lot of things can go wrong with manufacturing, and you will have many different sensors for that. When you collect the data with all these different sensors, how do you go to what really matters? What matters is what should be the patient doing to keep his asthma under control. That's what the challenge is, right? So from the data to what you call as an abstraction or decision making, there is a big gap, and that gap is filled by what we call this semantic computing and other things like that. On the right hand side, this is called the dashboard that shows you. You can find the correlation saying, here, look, this child is getting asthma every time air quality is poor, or things of that nature. So you can visualize that, you can get correlations, and then we develop AI techniques for finding causality. I won't go into details there, but the point here is that we need to understand that as in healthcare, manufacturing also, you'll have lots of different types of data, sensors, human generated data. From that to decision making is a challenging path, and that's what I wanted to focus on in one of the things here.
And that is very clearly the heart of what we're doing. So this is basically what you were talking about, right?
Yeah. So for example, earlier I talked about a gateway for network and protocol level interoperability, but now we have to talk about all these different concepts. On the right hand side, you see a little bit of graph, and all these different concepts. And what happens is is called semantic annotation, meaning you have a data item and you label the data item to say, oh, that is humidity, and humidity captured in this unit, and that is temperature, but it's an ambient temperature, not the device temperature, right? So these things are need to know. You get a temperature, but what the hell it is it in Fahrenheit or centigrade, and is it ambient temperature, or is it exactly where is it measured, at what time? All that has to be captured. So this next slide is there is a something called World Wide Web Consortium, and we were member of that consortium, and I initiated an activity that became a standard called Semantic Sensor Network Ontology. So this is a little subset of that standard that came about, but basically this is about how do you make all the sensor data annotated to make it meaningful. Like in the natural language, you'll say this is named entity. Remy Herrick is actually a name of a person, rather than just a character or words. That is called the annotation. Similarly, you have to annotate here all the data that you're collecting, and there are standards for that that give you better semantic interoperability, and that's what this slide talks about.
And it's really all about interoperability. It's all about the capacity for one system, for multiple systems, to actually communicate on, like, it is fair to say it's like coming up with a common language of a kind.
Yeah, exactly. And this one is common language for the data coming from sensors. Similarly, and so this is called domain independent ontology or knowledge graph. At the same time, you also need domain specific one, meaning that if you are talking about manufacturing of a screw is very different than you are trying to create a complex part. It's very different to create an assembly, and the language for each of them, you have the application specific or domain specific vocabulary. So you also need to be able to use that and annotate that so that the data becomes more meaningful.
Awesome. So data, information, knowledge, and wisdom.
Yeah, this is a very well-known thing in information system, and I think it's a very fundamental concept that I think is very, very important to understand. Suppose a machine gives you a number 150. In this case, it's on the left-hand side. So happens that that is a your blood pressure device, a measurement device. But 150 is just a number; it doesn't mean anything. The annotated data is that it is a systolic blood pressure of 150 mmHg. Now this is labeled data. It is more meaningful but not completely meaningful. Then say, oh, there is a health standard, and anything above 140 for systolic blood pressure, above 130 is elevated blood pressure, and you need to manage that. That becomes knowledge. But even that is not enough for a doctor to give you medication. A doctor has to find out whether that elevated blood pressure is because hyperthyroidism or hypertension, and then you give the medication based on that, right? So you're going up the level of abstraction. The same thing has to happen in manufacturing. So there is so-called model called ISA 95 model, and it is kind of has different layers, and it goes up at a high level of abstraction, as you can see there.
It is super clear. I think you gave, like, I mean, the example of blood pressure and how we make the context is I'm gonna pick it up and use it in my classroom as well.
Yeah, and here it shows that in factory future, basically you have things within the product itself, your distribution, you have factory, you have suppliers and logistics. So they are kind of horizontal system. And earlier we already talked about the vertical system, the three levels, and there can be more. That is what this talks about. And now this is all put together. Actually, this is from the proposals that we did, Remy. You see on the left hand side physical sensors. There's a digital twin. In the middle you see the knowledge representation. This is a knowledge ontology and knowledge graph, all the individual factual information that we have collected. And then on the right hand side you see fault detection as one of the AI techniques. If we have time, we'll talk about that. And manufacturing scene or event understanding. So, for example, understanding that there is a failure, there is some problem and defect in manufacturing is just one thing, but there is a process failure, that event occurred is yet another thing. And again, the AI systems that we will discuss to whatever time we have help us do some of those things.
Cool. All right. So this goes along with the previous slide, and
yeah, we can skip that. It just gives more detail.
All right, let's talk a little bit. We still have approximately 10 minutes. The good thing is we handle comments as they come, so please keep them coming. And let's talk about computer vision in manufacturing.
So the vision has one of the highly used area of AI in manufacturing, partly because also for the same reason that robotics is a highly used area in in manufacturing. And here are just some of the problems or that vision, computer vision can help you solve. The AI techniques are getting developed very fast now in each of these things: predictive maintenance of machinery, inspection of defective parts, accurate assembly of components, and such. So it's just a list of all kinds of problems for which you can call upon computer vision to help you with.
Cool. So inspection systems.
Right. So what basically you start with visual sensors or Internet of Things to monitor defects. Then they generate a lot of data, high volume of data. How do you make sense out of the data is very important. Now, for example, if the sensor is a visual sensor that is giving you an image, then certain kind of algorithms, I mentioned one of them, convolutional neural network is one of the deep learning algorithms that has been found to be very, very appropriate and helpful in many of the image processing problem. And I'll talk a little bit more about it in the future slide, or just a bit more. But and this is simply an architecture of one such system. You have cameras, you have data connected to sent to the fog node, and then that goes to the server. Now the idea here is that the default option will be to take all the data that goes to server, and there you run these deep learning algorithms. This particular work, I'm just giving you an intermediate flavor, has a intermediate layer. You can see early exit in the middle of the right hand picture. So the idea here is that rather than completely process the image, it's possible to identify do partial image processing, and figure out that something is wrong here, and don't have to then go to the higher level and put in all the additional work for that. So the idea is that this so-called early exit allows you to do the process of finding defects much more efficient than the default practice of taking all the data and taking it to big servers. And I worked also in hazard computing, disaster. But here also, drones are extensively used here, and drones basically give you images, and processing of those images to find what's wrong is done by this vision system. So suppose there's a drone inspection, you can pull up the drone inspection, and see what's happening manually, but the AI algorithms can be trained to find much more reliably the problems that are there. For example, if there is a on a grid, there is some part that is burnt out on the grid, on the tower. Identification of that by this AI algorithm is now can be done very, very well with very high quality results, often better than even humans can do.
I agree. All right, so leading into wrapping up, we still have a couple of charts. But so first of all, let me tell you, I mean, this is really a live stream on LinkedIn. Nothing says we have to stop at 1 hour. So if we need a couple more minutes to make sure everybody's good, then we can do that. There is a couple of questions that are coming up from Brian Prasad. I'm gonna leave them perhaps till the end. So we still have a couple of slides on predictive maintenance and whatnot, so we can perhaps talk about those and switch to answer the question. Does this sound good?
Yeah, I think this, this is simply, I'll just make a larger point. You've seen a lot of other pictures, CPS is cyber physical system, and, you have various equipments and sensors, and IoTs are there shown here. And then there are different kinds of signals that are being collected, and there's a box called feature extraction. So there's a time domain, time frequency domain, wavelet, and so many other things that are there. 10 years ago, we used to had to do something called feature engineering, meaning different of these features have different level of importance in ability to be able to identify the fault. Instead, and so there was a lot of so-called manual, machine learning engineers work that was going to be done, that used to be necessary in developing the algorithm. Now with these so-called deep learning algorithms, the feature engineering task is not required anymore. It gets done by the system, because the AI algorithm, deep learning algorithm, is very powerful in statistical analysis of the data, and it adjusts automatically which has more importance when outcome is already told by system when you create the training set for training this algorithm. So all these algorithms by and large are so-called supervised learning algorithms, although there are other variants coming on. And the point is that though there are machine learning or deep learning algorithms that are used to do the fault diagnosis and prognosis. So that's what it shows here.
So I think this goes along with what we talked about, predictive maintenance based on deep learning.
Yeah, and then basically there are two different parts. One is a prognosis, the probability that a system can fail in different time horizons. So the point is that there are these different measurements. You can see the working conditions or geometric maintenance, how fast the part is moving, and any change in that, any change in noise, any change in temperature, all that kind of stuff are being collected. And then these algorithms can predict the likelihood of the failure by time. So as the time goes, the likelihood goes more. You pick a time where you want to do preemptive maintenance, not too early, not too late. And that decision making itself an interesting process. And just wanted to mention that that is also being done.
Cool. So I think we are wrapping up. This is the last couple of slides you have.
Yeah.
So we're gonna talk about. So you've already mentioned them, but basically, you're talking about chatbots and smart manufacturing. Um,
I mean, now this natural language processing, the chatbots, the conversational AI is giving more ways for humans to get engaged. There was a question very early on about the humans, and the point is that humans may want to communicate. One human can tell other human by speaking to him. Well, with all the robots being put in, you can talk to now robots, or you can ask the questions and you can get the answer. So all of you have heard of seen Amazon and Alexa and Alexa and Google Assistant, all that. But they are becoming trained for not just what is the weather today, but to deal with a specific manufacturing process, and within the smart manufacturing. So humans can be integrated much more easily, much more comfortably with this kind of stuff. So you can do question answering with the devices.
I'm glad you didn't say what you said on a louder voice, because I have one of those equipment in the room, and it would have tried to answer you right now.
Yeah, I know.
All right. So the key takeaway. This is the last chart that we have.
Well, so I mean, these different aspects of AI. One of the most significant and time-consuming and yet rewarding part of the AI is one that helps you deal with all kinds of data that is generated during an automated manufacturing system. And what you're going to see is that the future differentiation between manufacturing companies is likely going to come from AI. With the machine, everybody can buy a particular robotic machine and deploy it with certain capital investment. The skill required for deploying some of the things like I discussed, data interoperability or semantic interoperability integration, is even more challenging, more consuming. Creation of knowledge graph and all that. That is where a lot of investment is being done now, and that's where you'll see not just uh, part production here, but integration across the factory, multiple connected factory connected with supply chain. So that broad horizontal scope is where a lot of investment is being made, and that will make a big differentiation going forward.
I cannot thank you enough. This has been so much fun. I love working with you. I mean, we've talked about this. We've been collaborating for quite some time. I really, really love working with you, and sometimes I'm impressed when you give me back feedback. I'm like, where does he find the time? How does he do it right? But this is like, I mean, as someone aspiring at one point in my academic career to reach your status, this is something that I'm learning. So thank you for that. We have a couple of questions, and then we wrap it up. So the first question we have from Brian Jacobs: how does UFSC partner with industry to ensure academia is developing technologies that can be monetized and will be embraced in production? I'm gonna take a stab at that. I mean, UFSC has a office, the Office of Economic Engagement, and they are super well positioned. And actually, they communicate all the time with industry, and they try to bring industry and do like matchmaking between industry and faculty. And I think this is one of the biggest strengths point at UFSC is OAE, the office, the people, Bill, Jay, Chad, Noble, and the whole group over there. What's your take on this? Because I've been here for 7 years. You've been here for a year. What is your take on this question?
Well, I myself have done 4 companies as a founder or co-founder, and 3 of them are actually licensing technology from my university research to start the company. 2 of them I ran myself as CEO and for a while, and then either they got sold or whatever. Others I just started it and then found the experienced managers. UFC is very well positioned. They have entrepreneurship office, as you mentioned, and they are pretty active and very helpful. By and large, the university has a lot of connection with industry. Remy's platform that you saw is also in collaboration with industry partners. So industry engagement is pretty natural to the university, and whenever we have the right things, I think we have many methods of doing that.
Yes. So Prasad is asking, has UFSC CAC published literature on intelligent manufacturing? And can you talk about it a little? So I think both of us can answer this. You want to start yourself?
No, on the intelligent manufacturing, other than this talk, I haven't, because I started really working with that after having moved here and working with you, Remy. So
Yes.
yeah, so I think we are. You just sent out a paper recently, and you have something else going on there. So yeah, I mean, those are just getting started now, and it'll ramp up as we have more students involved and more funding.
I completely I agree. So we actually already have a paper, Prasad, that is published in one of the most premium journals, Journal of Manufacturing Systems, on our work so far. This is led by Kaishu Jha. We actually have several papers, but there is a paper that we just submitted with Amit as well. So we do have a couple of papers. Reach out to me and I'll be more than happy. Or if Kaishu is still on the chat, he can reach out to you directly and we'll be more than happy to share with you. All right, so I left one question till the end from before from Dominic. Will there ever be an Industry 5.0? So I'm gonna let you answer that if you want, and then I can take a stab at it and answer it myself.
There will always be the next. So yes, in my case, my view is that by all means, and with all the certainty that yes, there will be Industry 5.0 and so on and so forth. They'll continue. We may come with different name than just 1, 2, 3, 4 industry, but yeah, there will always be that. So a lot more things are going to come there.
So it's awesome what you said. You said there will always be the next thing. And so Dominic, that's why my research team is called neXt. Because when I started working in this domain, it was called CAD/CAM, and then it moved to PLM, and then Industry 4.0, and then digital transformation, and then Internet of Things. And it's always continuously evolving. And if I wanted to call myself, like my research team, digital transformation or Industry 4.0, I will be obsolete in a couple of years. So this is why my research team is called neXt. And this is why this show is actually called neXt, because there's always going to be next. How do you like that, Amit?
Yeah, that's the perfect thing. Yeah.
All right, awesome. So Amit, is there anything else you would like to add before we wrap it up?
No, I think this is going to, only thing is that it's going to take very close collaboration, and I think that the incentives are there for industry to take this very seriously. So I anticipate that this area is going to grow really fast and will be very significant, part of the industry.
I thank you so much for this chat and all the work we're doing together. And we did stay a couple of minutes more, but at the end of the day, I mean, this is a very exciting topic and this is absolutely fine. Thank you so much, Amit.
Thank you. Thank you very much.
All right, everyone. Thank you so much for tuning in to this third episode of the season of our next live show. We're going to continue every Friday, 12 noon EST. There's another exciting topic that we're going to talk about, something that is important. Before I let you go, it will be great if you all can press this applause button for Professor Sheth and thank him so much. And I'm going to clap on your behalf. Bye-bye, Amit. Thank you.
Bye.
Ciao. All right, let's go ahead and end the broadcast. So there is a couple of people thanking you, Amit, Brian, Hassin, and I will send this to you later. Bye, everyone.